friction force between two solid surfaces. Look at the figure. An eraser is placed on an inclined book. The eraser has the tendency to move downwards because its weight is acting downward along the inclined plane. Despite this, the eraser remains at rest. In reality, a force of friction between the bottom of the eraser and the surface prevents the eraser from falling down. This force is called static friction. Static friction acts on a solid object only when its surface is at rest relative to another solid surface, while a force is tending to displace the object. This slide disproves the first misconception and shows that the friction force acting on a stationary object is not necessarily zero.
What is the reason behind the existence of static friction? If the contact areas between the eraser and the book are magnified hundreds of times, as shown in this figure, we observe microscopic irregularities. Static friction arises from microscopic irregularities between two rough surfaces.
In the figure shown, the boy is trying to push a heavy box horizontally to the right on a rough surface, but the box remains at rest. The static friction acting on the box is horizontal and directed to the left. In this figure, the block is at rest on the inclined plane and its weight tends to move it downward. The static friction acting on the block is parallel to the surface of the incline and directed upward. Therefore, static friction acts in opposition to the tendency of movement in a stationary object.
Does static friction occur when the object has no tendency to move? In this figure, the box is at rest on a horizontal rough surface. The box is not experiencing any friction. Static friction doesn't occur when the object has no tendency to move.
Does friction necessarily have a constant value when acting on a resting object? Let's watch the upcoming PHET simulation. In this PHET simulation, a box initially rests on a rough horizontal surface. As the person applies a force of 50 newtons, the static friction force adjusts to 50 newtons in the opposite direction of the applied force, cancelling it out and keeping the box at rest. In this simulation, the static friction is shown as acting at a random point on the box. However, in reality it acts between the bottom of the box and the rough surface. As the applied force increases to 100 newtons, the static friction force increases to 100 newtons, maintaining equilibrium. However, when the applied force gradually increases to 125 newtons, the box remains at rest, momentarily reaching the limit of static friction. When the applied force slightly exceeds 125 newtons, the box starts to move. At this point, static friction ceases and becomes zero, and a different type of friction force acts on the box. This will be studied later.
The previous simulation shows that the magnitude of the static friction adjusts to match and oppose the applied force attempting to move the object. Once the body starts moving, the static friction disappears. Therefore, this simulation disproves the second misconception and shows that the friction force does not necessarily have a constant value when acting on a resting object.
Consider the previous simulation where the box is in its at rest state. The maximum magnitude of the static friction is given by μs times n, where n is the normal force acting on the box, μs is the coefficient of static friction, which is a positive constant that depends on the material and the structure of the interacting surfaces. Typically, μs is less than or equal to 1.
Kinetic or dynamic friction is a different type of friction force between two solid surfaces. To understand kinetic friction, let's watch the upcoming PHET simulation. Going back to the previous simulation, when the person applies a force of 125 newtons, the box remains at rest and is subjected to a static friction force that matches the applied force of 125 newtons. Now, 125 newtons is the maximum value of static friction in this situation. When the applied force slightly exceeds 125 newtons, the box starts to move. At this point, static friction becomes zero, and another type of friction force known as kinetic or dynamic friction acts between the box and the ground. We notice that during motion, the kinetic friction has a constant magnitude regardless of the applied force and the speed of the box. Kinetic or dynamic friction acts on a solid object only when its surface is in motion relative to another solid surface.
The previous simulation shows that the maximum magnitude of the static friction is 125 newtons. When the box starts to move, the static friction is replaced by the kinetic friction, which has a constant magnitude of 94 newtons. Therefore, this simulation disproves the third misconception and shows that the magnitude of the maximum static friction is always greater than that of the kinetic friction. Also, the simulation disproves the fourth misconception and shows that the kinetic friction remains constant regardless the speed of the moving object.
Watch the upcoming crocodile animation to learn about the direction of kinetic friction. We notice that as the block moves to the right, the kinetic friction acts to the left, and as the block moves to the left, the kinetic friction acts to the right. Therefore, in most cases, kinetic friction acts in the opposite direction to the object's velocity.
Consider the moving box shown in the figure. The magnitude of the kinetic friction is given by mu k times n, where n is the normal force acting on the box. Mu k is the coefficient of kinetic friction. Similar to the coefficient of static friction, it is a positive constant that depends on the material and the structure of the interacting surfaces. Does friction always resist the motion of a moving object? Let's watch the upcoming short video. The worker places the box on the moving conveyor belt. Kinetic friction exerted by the belt accelerates the box forward until it reaches the same speed as the belt. Therefore, this simulation disproves the fifth misconception and shows that in some situations, friction force is a motive force that helps the motion of a moving object.
Now, let's sum up the differences between static and dynamic friction. Static friction acts between two solid surfaces at rest relative to each other, while kinetic friction acts between two solid surfaces in motion relative to each other. Static friction has a direction opposite to the tendency of motion, while in most cases, kinetic friction has a direction opposite to the direction of motion. The magnitude of the static friction is variable. The magnitude of the kinetic friction is constant. The maximum magnitude of the static friction is mu Sn, but because mu k is less than mu s, then the kinetic friction is always less than the maximum static friction.